And tonight's final keynote speaker is Shah Selbe. After his graduate education at the University of Southern California and Stanford, Mr. Selbe worked as a rocket engineer at the Boeing Satellite Development Center before moving into the conservation space. He recently founded the first solely conservation technology-focused makerspace and prototyping lab named Conservify. This organization focuses on how open source technologies can be leveraged to gather data and empower local communities through innovative tools that aimed at changing our planet's future. Join me in welcoming Mr. Shah Selbe to the stage.
I actually have to switch to my presentation. First of all, I want to thank the whole team here for putting this on. This is great. I'm a conservation technologist. So basically what you're doing over the next 2 days is what I do every day as my career, and it's absolutely amazing. So I'm going to tell you a little bit about what I do and just a few of the projects that I've worked on, and then I'll leave you with some words of advice on things that I've learned throughout this process on how to approach these problems and think about these problems. As was mentioned, I started my career in the space industry. I worked on propulsion systems for satellites, and working on space projects is incredibly difficult. We have to engineer and build something that we put up in orbit around the Earth, and it has to work perfectly for 15 years without anyone being able to touch it in some of the most extreme environments available. So it gives you a lot of insight about being able to build tools for very, very hard environments and climates. This was one of the satellites that I worked on. And since it is a complicated thing, sometimes it doesn't end in the best way. So this is what happened to this satellite behind me right here.
10, 9, 8, 7, 6, 5, 4, 3, engine start coming. 2, 1, go inertial.
So as you can see, it's going the opposite way it's supposed to go there. Yeah. And that company's no longer around because of that. But I went back to graduate school, and I started it was at Stanford University. I started working with this great organization there called the Center for Ocean Solutions. And the organization there is a lot of environmental policy and environmental lawyers and biologists that are working on great problems around conservation, but they didn't have any engineers there, and that's what I came in to kind of help them through, and it became an independent graduate study that I started working on way back when, and since then I worked with a bunch of great organizations, and in 2013, because of that work, National Geographic brought me in as one of their explorers. So ever since then, it's kind of just taken off, and we've done a lot of really interesting things since then. So, a couple years ago, I founded an organization, a nonprofit that would allow us to kind of do this, a technology development lab that's focused just solely on conservation. And I put it in the one city that pops into all of our minds when you think about wildlife conservation. It's in downtown Los Angeles. But it's a full prototyping lab where we get to build all of these tools and take them out on expedition and test them with scientists. It's a ton of fun. It's really difficult. The lab is pretty messy, as you can see. And we've had all sorts of failures and all sorts of successes, but that's part of trying to do something that people haven't done before. So some of the projects that we've worked on, one is we've done a lot of work with drones. Actually, in 2013, I had a grant. A lot of this stuff came from a grant from National Geographic to look at using drones to try and find illegal fishers that are out in marine protected areas. But we've also used drones to try and find, count marine mammals. Actually, in a few weeks, I'm going with the Zoological Society of London to Congo to use drones to map mountain gorilla habitats. So there's a lot of really cool stuff you could do with it. It's a very useful tool, but it is not a silver bullet. I can't tell you how many times I've gone to a place in the world and they've told me we need a drone to do this. And we always have to back up and say, well, let's figure out actually what your problem is, and then we'll figure out if a drone is actually going to help. We've done work with tracking animals. I mean, now it's a lot easier to create these trackers. I know the Duke Conservation Tech team is working on on an application here. We've worked with tracking sharks, and later on this year, we're going to be traveling to Antarctica with some scientists from New Zealand to track whales down there. So there's lots of cool stuff you could do it. Rainforest Connection was talked about earlier. So this is a really cool project that was started by another explorer and a good friend of mine named Topher White, which had a great idea of taking cell phones that people don't need anymore and putting software on them that can listen in the rainforest for illegal logging, listen to the acoustic signatures that come from chainsaws and motorcycles. Well, we got a grant from National Geographic to take that technology and adapt it to the ocean. So try and listen for vessels passing through in areas where they're not supposed to. So with that grant, we created a prototype. We put it in the Port of Los Angeles. We recorded a bunch of vessel noises as they pass by. And Schmidt Marine Technology Ventures is giving us some funding to kind of scale it out and take it to other places. So the cool thing about that is you could do a lot other than just figuring out if there's a vessel in an area from an acoustic. Actually, this is a recording that's playing right now. But from an acoustic signature in the water, you can tell if whales are in the air. You can tell a health of a reef system, and there's a lot of really interesting stuff you can do. There's some great research that showed that you could even tell from the acoustic signature the size of a vessel and the type of fishing the vessel's engaging in, how many props are on that vessel. There's a lot of really, really interesting information you can pull out of that if you know how to do it correctly. Another project that we currently have ongoing right now is a glacier monitoring project in Banff National Park, and so this project's funded by the city of Calgary. We put a bunch of geophones and accelerometers around a glacier that they were interested in understanding how it's melting and how it's changing over time. And we built this system that gathers the data from all the sensors and it streams it live down onto, we stream it onto the internet, but then that data is also going to be used for a massive public art installation in the middle of the city of Calgary. And then we worked with another National Geographic explorer and grantee, Andreas Russo, to do some water testing throughout this boiling river project that he works in the Peruvian Amazon. Andreas is a really dynamic guy, and I'm not going to talk much about the project because he's got this great TED Talk, so you can go and find him if you want to learn more about it. And finally, one of the other things that we've been working on is trying to make sensors a little bit easier to use for scientists and citizen scientists and folks that are out there. So we created this, or we're working on this platform called FieldKit that really came from some work that we were doing on a National Geographic project in the Okavango Delta. For a couple of years, we'd been working on creating this platform that involved sensors and data visualizations. And wanted to turn it into a product that anyone can use. So we went through a bunch of prototypes on what sensors would look like for that, and we created this three-pronged approach that has sensors, an app, and a data visualization platform. It's not fully released yet because we're still working on it, but the idea is that anybody who wants to go out there and gather data about the world around them, or they want to be able to input any sort of information in, and then create a great visualization out of it. But the one thing that we kind of focus on when it comes to all of this technology and even this FieldKit stuff that we work on is we want all of our stuff to be open source. That's like a major principle of the work that I do, is that it all be open source. And so I'm sure many of you guys really know what that means, but in the past, when people would develop technologies, they would hold that intellectual property very close to them, because that was their source of profit. But we saw in the software community that you could actually do a lot of really cool stuff with open source software. So we work primarily in open source hardware. And it also helps us too, because we're a small lab. So a lot of the collaborators and people we work with are full-time engineers that are working in some area or doing some sort of thing. So we're starting to try to build this open source sensor library with the one goal of trying to bring down the cost of how much it is to actually go out there and do some environmental sensing out in the world. If any of you guys are scientists and you've tried to find tools to go out there and measure the world around you, you can see that a lot of the options that are available are very expensive. And there's a lot of opportunity in reducing the cost of those things. And if you reduce the cost, then those grant dollars can go so much further, right? You can buy more buy more hardware, measure more things, spend more time out in the field, and do a lot of really interesting stuff as a result of that. So this work that I talked about, these were just a few of our projects, but it's taking us to all these places in the next year. So there's a lot of like really exciting stuff ahead, and we're always looking for help from people to do that. So now I'm going to talk a little bit about conservation technology and the way we think about it when we're coming up with a solution. So conservation technology, you know, as a field is fairly new. Technology had always had its place in conservation and science, but it was less formal, right? It was you know, if you're a scientist and you're working in conservation and you need to develop a tool, then either you buy something off the shelf or you have one of your PhD students create something, and that becomes something that scientist uses for the next 15 years. But if we start to think through like the innovations we've had in the technology space with smartphones and sensors and the internet and all this stuff that we're able to do now, and apply it to some of these problems, we can really start to change the way we do things. So, you know, all these sexy technologies you hear people talking about, there's some person in the world right now that's trying to figure out a way to apply that to conservation. That's a really, really powerful thing. So, you know, it's a bit of understanding, you know, engineering design and what goes into designing a solution, but also how you deal with it in the field, how, you know, the human-centered design type approach when it comes to that. So, you know, we've kind of, when we think about designing a solution with an organization or when we're working with a scientist, we kind of go through this general process to go through it. And so I'll talk a little bit about it. So when you're thinking about this stuff over the next day or so, try and keep these in mind as you're going through. I think the first part is we really try and understand the problem. Like you can't quite design a solution unless you actually know what the problem is. This is one of the first main problems we always run into when it comes to working with someone. People call you in and say, we need a technology solution. We need to do a drone for this. I think we can do satellites for that. But you always have to walk it back and really understand what the core problem is. I mean, this is how engineers work when they're designing something new. You know, they start at the requirements. They kind of dial it all the way back from the beginning. The next is what I call map the resource flow. But what I mean about resource flow, and I mean like, what are all kind of the externalities around this thing that feed into it? We're like, where does the money come from? Who are the people involved? Who are the stakeholders? Like, what kind of supplies do you have? How close are things? Like, you know, what's the range? You really have to understand everything that feeds into that project before you can design a solution around it, because it really it drives a lot of that. And by mapping out that whole system and really understanding how that system is, you can find like where that core gap is, and so what you actually need to fill to solve the problem. And oftentimes when you're working in the field, this is very different than what the person who asked you to come into the field thinks it actually is. So it's usually something that that can be solved easier or in a different way that can actually solve, you know, the problem that they're actually facing. Constraints are a big thing too. So, you know, it's very easy to think about developing an app to do X, Y, and Z, but like if you have to really think, is that app actually going to be effective in what you need to do? So enforceability is one big thing. You know, we can go out and take our smartphones and take pictures of boats that we think that are illegally fishing, but those pictures have to do something, right? They have to go somewhere. And if the pictures aren't able to be used in the courts to prosecute these people who are doing illegal fishing, or if they're not, if the pictures don't actually show any fishing activity, you know, it's not actually going to solve the problem. So you have to think about that. And then another constraint that you really have to pay a lot of attention to is technological capacity, right? So you're not going to design the most technologically capable drone ever conceived and then take it to a place that doesn't even have electricity, right? So you really have to think through what are the needs and the constraints. And I put here governance and demand, because that's a big thing in designing a solution. There's some parts of this world and some conservation problems where really all it is you need to find data and give it to the right people, and that could solve the problem. There's other places that if you find data and you give it to the people, the data disappears and nothing gets solved. So maybe the best idea there would be to find the data and show it to the world, or or do another way. So you have to think through what it is, that structure that you're actually working within, and how to actually come across and do that. And the other things just would dictate what your solution ends up being. What's the size of the area that you're trying to monitor? What is how do you maintain it and keep it going, and things such as that. So the next step in the process is you design what you think your solution is, and you build a bunch of prototypes. This is like pretty self-explanatory, and I think there's going to be some time to be doing that over the next couple of days. One thing I want to say about that is to really kind of try and think outside of the box. Think wild when it comes to this sort of thing, because from a global conservation standpoint, we're not in good shape, right? We're not doing it well. I think you guys have all heard the negative statistics about things. I'm not going to repeat them right now, but based off the tools that we're using today and the way that we actually do things today, it's not working. So we really have to start thinking outside of the box, and that's what I'm hoping a lot of you guys will be doing over the next couple of days. So the next after that would be to pilot carefully and quickly. So I say pilot carefully because a lot of times if you design something and it doesn't work, that could leave a bad taste in the mouth of the folks that are actually using that out in the field. So if you design your piloting and your deployment process in a way that has steps or is measured, you can kind of stop a lot of that. I've seen so many times where communities or NGOs have decided they want to have a project. I'm picking on drones a lot, but I'm going to pick on drones again. They want to have a drone project, and they just find the first person who flies in with a big expensive drone, and they try it, and it crashes, and they're like, "Oh God, drones will never work in this area," and because they didn't really think about how that would work once they actually pilot and deploy it. Part of that is to be very participatory when you do this. You want to think about these solutions as not something that you're sitting in your ivory tower and you're creating the world's silver bullet, and then you go into this place and they have to use it because it's brilliant. Like, this is the best idea ever. Why are they not using it? We usually, in being participatory, it's like human-centered design, right? You bring people in early in the process. You make them part of it. You want the folks who are actually going to be using this tool out in the world to own it. This tool doesn't belong to you, it belongs to them. Because if they have ownership over it, that means it's going to keep on being used, right? It's going to be maintained. It's actually going to make a difference, right? So the participatory aspect is huge, and there's a lot of really great stuff, especially the citizen science and crowdsourcing type stuff is really great at this, is at getting people engaged towards solving the problems. And then you want to track and measure your progress. Yeah, you want to make sure that what you're actually doing is not making things worse, right? It's making things better. So it's important to kind of pay a lot of attention to that. So that's like the general high-level framework that we usually use when we're thinking through these sorts of things. So as you guys kind of think through it, I think you should pay a lot of attention to the crowdsourcing and the citizen science stuff. I think there's a lot of potential there to do some really great work. And then I also wanted to say there's a few things you can do beyond this. So once you leave this place, if you're inspired by the work you do here and you want to give back, Conservation X Labs has this great tool called a digital makerspace that you can sign up to, and you can participate on some of these ideas, or even list your idea on here and try and find people to help. National Geographic right now is doing this Marine Protection Prize that actually in a few days the registration is ending. So if you do want to try and develop solutions around that, you should definitely check out this marineprotectionprize.com website, and you could potentially participate in something that can bring a lot of money. You see Logan Martinez there. Eric's right there. That's an earlier picture. So hopefully that helps you guys in thinking through the sorts of things that you're going to be working on in the next 2 days, and I'll be around today to talk and help if I can. So, thank you.